Hey, everybody. Good morning, good evening, good afternoon, depending where you are. Very excited that you're here to join Bruno and I talking about Terraform and Shipa better together. Really talking about building an internal development platform IDP. You're going to be leveraging today. We're going to be leveraging Kubernetes, Terraform, and Shipa together to take a look at how everything's possible. If you have any sort of questions, feel free to post them in the chat as a question um, or as a chat question. And yeah, first question will be recorded. Yes, we'll share that out. So thanks for that. So just diving in. So welcome everybody once again. So there's two of us on the webinar today. So I'm Ravi Lachhman. I'm the field CTO of Shipa. Previously, I worked at places like Harness and Mesosphere and Red Hat. So distributed systems are my game. And Bruno, maybe a quick introduction of yourself.
Yeah, I'm a frustrated musician. I couldn't make the cut, and I was not good enough. So I moved into software engineering. Not good enough as well, but too late to change at this point. So yeah, one of the members here at Shipa, and Shipa is my second venture. Excited to help folks deploy and manage and secure applications.
Sweet. Maybe you can play some music for us towards the end.
I keep saying that. Yeah, we should do a jam. Like so many people play in our space. Yeah, maybe next one.
Awesome. So, what are we going to talk about today, other than some guitars? We'll be talking about. We'll kind of set the stage for about 10 minutes here, just about hey, why is looking at these two or three technologies important at all, right? So the rise of engineering complexity and actually how that started to creep in. And then talking about one of our core concepts here, AAC or application as code, kind of introduce that as a concept. So how does that complement IAC with application as code? And then what everyone's going to be waiting for is actually showing Terraform and Shipa together. And so kind of starting off here at the very beginning is that engineering fatigue and complexity, right? So as an engineer, how many times have you heard just figure it out, right? So, we're typically, I always get this call from my sister to help her fix her printer, no matter how many years go by, her printer always breaks. And things, well, you're, in software engineer, like, can you fix my printer? Well, that kind of mindset has boiled into a whole bunch of tools that we use, right? So if we take it back, when I was coming out of university, my background was in J2E or JEE, and this is what I have to focus on, right? So depending on who you are on this call, if you're a software engineer, this is what they put up with. If you're a DevOps engineer or a platform engineer, this is what your internal customer is going to be going through, right? And so kind of personifying a software engineer, pretty simple. I wrote Java, a couple pieces of language, I deployed to a couple of systems, and usually a middleware engineer would take over and take care of that deployment. So very, very, very focused. If you take a look at what ends up happening today, and this is where like fatigue and decision fatigue and a whole bunch of toil and frustration is, that I'm the same person. I have less hair and I got bigger, but same Ravi, right? We have to worry about so much more, right? Not only that the Java language has more granularity, is that okay? We're using a lot of open source. Oh, also, Ravi, you have to learn how to build it, and also lay down some infrastructure, and also you have to package into Docker, and also, surprise, we're in Kubernetes. And also you need to use a package manager like Helm or a configuration manager like Kustomize. And then we also use Fluentd for tracing, and then we're on AWS, right? So the amount of skill sets that need to happen has increased a lot, right? And who owns all of this, right? Like this eye chart of icons, like who owns all of this? Is it a system engineer who owns that? Yeah. Is it the developer? Well, you wrote it, you run it, right? Is it this DevOps engineer? Or this mythical release engineer, like who's on the missing milk carton if you have a release engineer at your firm still. So this actually plays into something called Conway's law, right? So your organizational structure will follow how people communicate or what skill sets you have, and it might be a combination of all these people here. And so let's talk about a core concept of us called AAC, application as code. So we're going to kind of go on a little bit of a journey in the next 2 or 3 minutes, going from static deployments to infrastructure as code deployments to now the next evolution there will be building that with application as code. And so a decade ago, right? So take it back to the 2010s, right? So as a developer, I have a couple pieces of infrastructure that I need, and they're typically deployed on a virtual machine. So I might say, okay, I need to build something. So I have my own instance of, our team has an instance of Jenkins. I might have my own application server. You might be having your own artifact repository too. And my friend here on the right, who's a system engineer, he'd be kind of the one in charge of provisioning that for me, right? So he might have some scripts. Even as we keep, I might provision my own or have blank VMs for my dev environments. As it marches towards production, Bruno will provision in any sort of like vSphere or VCAC or whatever. Like he'll be provisioning certain pieces of infrastructure on all different types of languages and configurations. Just preaching to the choir here. If you remember lead time, it could take a couple of weeks to get a VM. It could take even, I don't know why networking always took the longest. Like it takes a month sometimes to get a networking change in, and getting a new application server dev was pretty snappy. Those middleware engineers were on top of it. But there was 3 separate people who did that, right? So keep that in mind. And then as we start rounding in, after that, there's has to be a better way to do this, right? And so this is where this infrastructure as code, right? So Terraform, Puppet Chef, we focused on Terraform today, really came into play. But there's benefits to IAC, and this is going to be boiling into benefits. Some benefits of AAC also is that, well, IAC is repeatable, right? And so you can call it over and over and over again, right? And you'll get the same result because you'll get a consistent result no matter how many times you call it. And the big thing there is it's callable. So this whole rise in CI/CD, your continuous integration, continuous deployment delivery, is that you're able to integrate infrastructure automation into your deployment process, right? And so similarly, this actually ushered in the next generation of engineers. And so if you take a look at how our roles are changing, and this is going to kind of show the need of AAC, is that now if you take a look at very modern firms, I'm a little bit of a pessimist about this approach, but I'll have to don't shoot the messenger here, right? Is that a lot of software engineers, if you're looking at Valley and whatnot, they're turning into full lifecycle developers, right? You write the service, you have to run it. And the going joke is, well, you wrote it, so you have to know it. It's sure, I know the feature, but how do I know if it's healthy or not? Some other team versus now Bruno keeps getting promoted. He went from system engineer to platform engineer now. Is that he is more of a purveyor of the platform, right? He's purveying the Kubernetes clusters, making sure that the cluster has capacity and it's robust if I have to place workload on it. And also he provides tooling, or his team will provide tooling on, if I have to onboard or offboard applications, right? And the big draw to that is, as the second half of that Terraform and Kubernetes equation there, is that Kubernetes changed the game, right? Kubernetes has really allowed most people to speak the same. At least here's a manifest, right? A very simple manifest, but we're the operations team, the application infrastructure team, and the app dev team, they can kind of speak the same language. There's code where there was not code before. So instead of writing these fancy F5 rules and waiting for a month, Istio is a service mesh. You can just literally create a Kubernetes manifest and some Kubernetes objects that will, easier said than done, kind of define those routes. Actually, F5 has a service mesh now, ironically. But there is something that is missing, right? Given all the advancements in infrastructure as code, given all the advancements in Kubernetes and that particular cloud native ecosystem, there's still a few things that are missing, right? So as a software engineer, sure, I wrote my application and my feature to be compliant. Well, compliant with an asterisk, right? Hey, I passed our security scans. I went through all these hoops with quality control, quality assurance. I got a Sonar Cube. I got a B-, right, in my code coverage. But there's internals that I'm not familiar with. I'm not a kernel engineer by any means. A lot of these Kubernetes internals are, very kernel centric. I know that my application has traffic coming in and traffic coming out. But other than that, it'll be a little more difficult for me to explain how to set stuff up. And the going joke is Kubernetes is implementation detail. As a software engineer, or even previously a software engineering manager, it doesn't matter to me where we're deploying the application. Someone else, and this is my friend on the right here again, Bruno. It's an implementation detail. It shouldn't burden me where we're deploying it. Why is Kubernetes taking so much out of it? And now there's this litany of tools. They kind of shifting stuff left. Oh yes, Ravi, right? The pipeline and Argo manifest, and then also you get to use Istio, and here's if we monitor our clusters with Rancher. The soup goes on and on. Who owns all of this? And so this is now going to be introducing AAC. Application as code, exactly what engineers need, or specifically exactly what your development software engineers need to be successful. And so no matter where you are on two sides, if you're a platform engineer having to build these particular guardrails, or if you're a software engineer having to consume and live within this particular operating model here, application as code is actually a fairly flexible and very powerful concept. First of all, you can define policies, right? And so certain policies might be You have the ability to talk to certain applications, or you have to submit to security scan. Basically, all these non-functional steps you have to march towards to get your application out there is defined with application as code. It's a policy, right? You can limit certain things. And just defining applications, right? Like, hey, this is a tier 1 application at a bank, or this is a tier 2 application at an e-commerce firm, or tier 3. You can start bucketing these particular applications into different tiers, right? And so how do you define an application in the standard way with syntax to syntax, and that's it. And with Shipa, as well, today we'll be demonstrating on Kubernetes primarily, but you can actually define multiple pieces of infrastructure. So, hey, you know what? This will go to Kubernetes. This might go to EC2. This might go to some sort of VM. But also, applications code helps wrap in some like infrastructure. And then also with Shipa, we have the ability to quote unquote support and report. And so what that means is that we can give you health metrics of your application. We can kind of show you, hey, kind of an audit trail of certain items that someone deployed something, what's happening inside or happening to the particular lifecycle of the application. And so all this gets wrapped up into application as code. And so I'm going to be talking about really quickly, so where Terraform kind of steps in is Shipa has a few required objects and concepts to be created. And so Terraform will actually be starting all that for you. And so the bare necessities, as I call it, as an ode to the Jungle Book. So kind of let's look at the first concept in Shipa. So like the lifeblood of Shipa is this item or this object called a framework, right? So it's a logical definition of all your controls and policies. So imagine as a software engineer, I talked about, I know traffic comes in, I know traffic comes out. Well, with a Shipa framework, in plain English, you can define, hey, you know what, if you're the payment portal, you're allowing all traffic to come in, but you can only talk to the billing engine, right? That's fairly, logically that makes sense. But if you had to go and create that in Istio or Trafic, it's a lot easier said than done, right? So we can define that in a framework. Also, hey, you know what, going back to, I need to have some sort of security scan for my application. You can define that in a framework, and also limits, right? Like you can't have unfettered access to the cluster. You might limit my number of replicas I can have. You might limit resources. And also having, from a security concept, some RBAC access, and also like specific repositories that you can pull the image from. So we'll be setting that up with Terraform. And the next thing is the actual application, right? So the second concept is in Shipa, applications are bound to frameworks. And so this might be, hey, my application might be a particular image. It might be, hey, that might be this WordPress .latest tag or :latest tag is my application or source code. With Shipa, we can build from a build pack. And then also with Shipa, we actually, if you don't have one, we can create an address for you, right? So using one of the supported ingress controllers, if you choose, we can create a publicly accessible endpoint. So a lot of my biggest consternations was networking. When our application deploys, make sure how quickly that is to click on it, and then still also defining a team, right? Hey, not from a business control model. Not every team should have access to all applications. We can limit that inside an application. But with that, I'm going to pass the ball over to my buddy Bruno. So when we're talking about a match made in heaven, Terraform and Shipa. So Bruno, I'm going to pass it over to you. I'm hoping this works because I'm the host now. So
there you go. Can you? I assume everyone can hear me at this point.
Yeah.
Okay. Sounds good. So thanks, Ravi. That's right. So as Ravi mentioned, we're going to be covering kind of how different pieces they come together, and from an application as code perspective, how different components, such as the policy frameworks, and the second component, the application definition, they come together in a common developer portal, or an internal developer portal. Let me try, if the demo gods are with us today, I can try sharing my screen at this point. Let me see. 1 second. Share screen. Oh, you have to make me the host now, I think, Ravi.
Let's see. Let me see. So I got Bruno. I'm gonna make you the host. It might make it log back in. So if you see us like disappear for a second, like don't worry, we're still here. All right, boss.
All right, there you go. Share screen. I can share my screen. Yay.
There it goes.
I assume you can see my screen now at this point. Okay. So what you have in front of you right now, it's Shipa's dashboard. As mentioned by Ravi before, we have three main components, right? One is the policy frameworks, which is where now us as a developer platform, we want, or a platform engineer or a DevOps or whatever name, right? It changes every month, or new acronyms are added every month. Our goal is to provide Kubernetes as a service to our end users, right? Let's say our organization is adopting Kubernetes, is adopting microservices, but Kubernetes is not the greatest platform to provide raw access, let's say, to our developers. One, because Kubernetes, the cluster itself, you need a lot more for your applications to run, right? You need monitoring, you need policies, you need so much more for your applications to be running. It's point one. And point two, we want to make sure that whatever we put on top of Kubernetes or we deploy on top of Kubernetes can be controllable, right? And that's where we, as platform engineers, we use Shipa, or DevOps engineers, we use Shipa to enforce policies or define policies. And as we bind these policies to the cluster, it becomes a scalable model, because these policies, they bring all the other things that we're going to be showing together from a developer platform. So that's the first part we're going to cover. As Ravi mentioned, we have policies defined as part of the application as code. I'm going to show you how it looks like from a dashboard perspective, so you can see, kind of have a better idea or a visual idea. And then we jump into Terraform, how you can actually use Terraform to create those. So here on the Shipa dashboard, where you can, if you're not a Shipa user yet, you can sign up under apps.shipa.cloud, which is kind of this one here, apps.shipa.cloud. And I'm in the framework part. If I come and create a framework, I have two levels to get started, right? Basic, which is kind of the bare minimum you need to run, but you have the advanced model, which is where we can see all of the policies, or most of the policies available to us. So here you can define things as the name. So let's say this is dev or project one, for example. You can select which ingress controller you want applications that are deployed using this policy to use, such as traffic or traffic, I never know how to pronounce it correctly, or Istio, or so on. You can define things such as resource consumption, right? So you can say, hey, for applications deployed using the dev project one policy, they only should be able to consume 100 and something megabytes of memory and X amount of CPU, for example. And only the Shipa team, for example, or project one, project two can use this policy to deploy applications. You can keep on going on and saying, this is how much applications deployed using this policy can consume. These are the registries that should be allowed when developers are deploying applications using this policy. So you can come here and say Docker IO, Shipa software, for example. So anything that is deployed outside of this Docker registry, basically it's canceled or blocked. You can define default network policy. So you can say, hey, for applications deployed using this policy framework, I want to enforce some default network policies, but I also want to enable the developer or the owner of the application later to change those policies. And you're going to see how cool they look, and much easier than having your developers to actually drill down on the policies. You can come here and say, well, I'm going to do an allow all for both ingress and egress. And I can even say, what level of security scan I want to be enforced when applications are deployed using this policy. And if I'm binding this to an existing cluster, I want Shipa to map applications that have label app, for example, and start surfacing that. We're going to cover that in more details later. But that's kind of some of the policies that you can define from a framework perspective. Now, how does that look from a Terraform perspective? I have here my terminal. I hope, is it good enough in terms of size, Ravi?
Oh, it's perfect. Yeah, I can read it.
Okay.
Usually I have to squint, but this is perfect.
So now let's say we have Terraform, right? I have my policy definition in here, and it's exactly the same thing that you have from the dashboard, but looking from a Terraform perspective. Let's say me as a DevOps engineer or a platform engineer, I stood up a cluster. This cluster has nothing else installed. This cluster doesn't have Prometheus. This cluster doesn't have even ingress, right? You don't have anything. You just have a cluster, a bare cluster that you stood up on GKE or Oracle Cloud or whatever, and you use Terraform. Now, the next thing we want to do is bind a policy framework to that cluster. I'm defining here the provider, so I'm using Terraform provider for Shipa or Shipa provider for Terraform. And the next thing I'm going to be defining is the name. So I'm going to be following pretty much the same definitions that we saw, or as much as I need from those definitions that we saw on the dashboard. And one thing that is important to understand is that one policy, let's say I create a dev TF policy in this case. This policy is going to, when you bind it to your cluster, this policy will automatically create a namespace called Shipa-dev-tf policy, for example. So every policy that you bind to a cluster becomes a namespace. So as developers, they deploy applications using this policy, basically it goes to that specific namespace. So here I'm defining some of the things that we defined before, right? Security scan, which ingress controllers applications should take, how much they can scale, the access, the resource plan, and so on. I'm keeping a very kind of open policy in this case. Of course, you can customize it and use different policies. You can have a policy for dev, a policy for QA, production, and so on. So you can come here and say Terraform init, for example. Now you're going to see how bad I am with Terraform, actually. But you get the idea.
There's 3 basic commands I always remember: init, plan, apply. If you have those 3 down,
I don't even do plan. I just do apply and destroy later. So I try to roll back. So here I initialize my Terraform, and then I'll do Terraform apply in this case. And it shows me everything that I'm going to be creating from a policy perspective. Okay, it says it created the policy, right? If I go now to my Shipa account, I can see my dev TF policy. So now creating Terraform, using Terraform, we created a policy without having to deal with the API version of the cluster. If it's GKE, AKS, EKS, I'm not building Terraform policy specifically kind of trying to mimic Regal rules or Helm charts or something specific to EKS or AKS or a specific version. I'm defining policies in a scalable and in a way that can be replicated across multiple environments. Now, once this policy is defined, the next step for us is to bind that policy to a cluster. The policy is not bound anywhere yet. So if I were to bind a policy using the dashboard, what I would do is I would come to the clusters page. I would click on add cluster. I would enter my name on the name of the cluster, not my name. OKE cluster 1, and I would select one or multiple policies. You can bind multiple policies to the same cluster, and every different policy bind to the same cluster translates into a different namespace in your cluster. In our case, I would select this one, the dev TF policy, and next I would enter some information for Shipa to reach out to my cluster, right? Such as the DNS IP or the IP URL, a service account token that you can create so Shipa can connect to that cluster, and the certificate for that account to connect to your cluster. Those are the steps that you need to connect a policy to a cluster and translate that down into a namespace. If I'm using Terraform, you can also replicate this from Terraform, for example. So you can embed that into your pipeline and have a way to kind of rerun that every time you need, right? So if I go in here and say clusters, I have my cluster definition in here, which the same way I'm kind of initializing Terraform here. And then I'm passing it some pieces of information, such as the same pieces that we saw on the dashboard, the cluster address, the CA certificate, the token for my account, and which framework or policy frameworks I want to bind to that cluster. I'm going to use a cheat sheet. I already have that created somewhere. I'll just copy and paste so I don't have to bore you to death with that stuff. Resource, let me see. I should have created the entire file. But there you go. So I basically just pasted the file. I hope that works because I didn't check the indentation and anything, and you folks know YAML, right? The one thing I have to fix here is the policy name, right? So if I go here into my Edge and I use Microsoft Edge, it's not great. It's not bad. It's okay. Just in case you were wondering, it's worth a try. I'm sure some folks on the call on my team, they don't like it. They like Chrome better, but
that's why we have them muted, so they can't say anything.
Exactly. If you're an Edge user, just say hi. We love you all too. So you can select one or multiple frameworks or policies to be bound to that cluster, right? So, okay, I think I've got it. And you can pause, you can copy this, the certificate and all that stuff, but don't worry, we're going to delete the cluster after, so don't even spend time trying to do that. And as you know, if you're a Terraform user, Terraform, you can have those secrets injected from other vault or variables. There are just so many options to deal with it. I'm super lazy, and I wanted to kind of go through something easy with you folks today. But I have it ready. Let me just make sure I have the right cluster IP address. If you go to our documentation under learn.shipa.io, under Kubernetes cluster, connecting cluster, you can see exactly how to get your cluster IP, create a service account for Shipa, and so on. And just make sure I have the right cluster IP. There you go. I probably do. If I just do this, is it the right one? I forgot to check. Done. Yeah, it's exactly the right one. So what I'm going to do now, Terraform, init, same thing. And then I do a Terraform apply. Let's see if it works again. It didn't test before. Living on the edge.
Using Microsoft Edge.
Using Microsoft Edge.
I'll teach you about the tick auto approve. So even more on the edge. Terraform. So crash and burn.
And it's hard to kind of pick up one specific because one of the components that Ravi mentioned from, we can see that it's probably in the events page at this point. Yes, it's connecting the cluster. Great. So it's working. We just got to wait about 30 to 60 seconds for the cluster to be connected. But while it does that, one of the things that Ravi mentioned is the application as code is the definitions are generic, right? So today you might be using Terraform. So if you come to integrations and then Terraform, you can see the framework definition in detail. You can see application definitions in detail that you can use. You can create plans, user teams. So you can replicate your entire infrastructure using Terraform, right? And everything that you're using is very application-centric rather than Kubernetes-centric. So you detach the application from the underlying infrastructure. So if tomorrow you move to EKS or AKS, whatever version, you can bind the same definition to that cluster. But if you have Terraform, and let's say a team in your organization wants to start using Pulumi, for example, you can use the exact same definition other than the HCL boilerplate, for example, or JavaScript boilerplate. You can use the exact same definition to create policies, to deploy applications. And same thing if you want to use Argo CD or Crossplane, for example. Because you're finally detaching application from infrastructure, you can move between different providers and use the same definition. You're not going to have to learn how to deal with Pulumi deals with Terraform, with infrastructure, or how Crossplane defines infrastructure. Same definition across multiple tools, but the component is usable across multiple tools, right? Okay, the cluster is connected. Yay! I didn't mess it that bad. So you can see it is here. It's connected. And if I go to cluster, I can see my Oracle Dev cluster. I'm using Oracle Kubernetes on this one. Experience is pretty good, actually. And you can see the provider, and you can see here. Great. So me as a DevOps engineer or a platform engineer, I did two things. I created a policy. I have a cluster running with nothing, no ingress, no monitoring, nothing. I came to Shipa, I created a policy, and I bound that policy to that cluster. There's something there, but get namespace, for example. I bound that policy to a cluster, and I can see it created the namespace that I just mentioned for that policy, right? And as Shipa binds the policy to the cluster, if you don't already have an ingress controller, Shipa will automatically install an ingress controller for you. You may not have monitoring, like I mentioned, it's a bare cluster. Shipa will bring in monitoring to you. So Shipa takes your cluster from a bare or raw cluster to a production ready or consumable cluster for your developers. So you as a platform engineer, you don't need to be installing Prometheus, OPA, and all that stuff together to make it work. It becomes a lot easier for you. Now it comes the last part, how can developers consume this, right? Which is the application deployment piece. Developers, it's not uncommon for developers to say two things. One is, I don't like having to deal with Helm or customize, or I don't understand Kubernetes. And the second thing is, I don't understand what my application becomes once it runs, right? So this is the part where using Terraform and Shipa together to build that app developer platform can help you. So if I come here to apps and I do app deploy, for example, my definition, I can see here I'm defining my application with the name, application name. I can just change the name here. Let's say TF app demo. I'm saying as a developer, I'm choosing which team is going to be the owner in case I'm part of multiple teams, project 1, project 2, or team 1, team 2. I can choose, and I can choose the policy framework to use to deploy my application. Me as a developer, I don't have to know if it's GKE. I don't have to know if it's AKS or whatever version, if it's Helm, or it's seamless to me as a developer. I'm just pointing my application definition to a policy framework that was provided to me by my DevOps team. And here I'm saying, hey, I'm deploying this application. And here's the image, a very simple image, right? I'm deploying a potato head, which is an image most folks use in the CNCF channel. It's cute. So I'm defining this here. I can do same thing, Terraform init. It's initializing. And then my Terraform apply. And again, the same definition that I'm using to deploy my application using Terraform, later on, if you as a platform engineer, you want to try Pulumi or you want to try GitOps, for example, you can keep the same consistent developer experience and definition of defining apps using any of these tools. So you as a DevOps engineer, you're free to move and try different tools, right? And evolve, because that's what we do. So it says it finished. If we come to our applications, I can see my TF app demo running here. So as a DevOps engineer now, from a raw cluster, you can quickly go to services that you can give your developers to consume in just a couple of minutes, right? You don't have to be installing and dealing with so many open source components. And now you get a developer platform that your developers can finally manage the applications themselves. And they can come in here and see parts of the application, environment variables that they used, domains, config maps. They can see monitoring that Shipa hooks up automatically into your app. Remember, your cluster is a bare cluster. There was no Prometheus, nothing installed. Plugged in Shipa on top, and now they get this. So they can see that directly. They can see resources. They can see everything that happened to their application, who created, when it was deployed, scaled up or down, and you can see the log associated to that. So now it starts giving the developer a pretty good idea of what happens to their application. And also, SRE folks and DevSecOps, because they can come here and understand who owns the application, who owns the service. You can directly from here connect into integrations such as Slack or PagerDuty, OpsGenie, and so on. See network policies. And another thing that you can see is developers, they often say that they don't understand what their applications become on Kubernetes. So they can see, okay, here's my pod info demo that I deployed. And here are all the objects that Shipa created for my application to be able to run in that cluster, right? And the details of each of those objects. So now I understand my application, not only from an application object dependency, but from a service to service communication. So if you define a service saying application 1 can only connect to application 2 from another policy, then you're going to see these maps getting updated. So you know your service to service communication. That's it. So from my side, Ravi, we had a raw cluster. We connected a policy. Instantly, we got something that we can deploy a common application definition that you can give to your developer. So you get out of the business of trying to kind of build Helm charts and maintain these things. And every time there's a new service or a new cluster, you have to change, and getting a developer portal, all using Terraform in our case today. Does that make sense?
Makes sense to me. But yeah, I'll pitch it back to the audience. If you have any questions, I know that unfortunately for this kind of the setup of Zoom webinar, we can't, unfortunately the participants can't talk, but if you have any questions, put them in the chat. And this doesn't have to pertain to Shipa either. I mean, we can answer any sort of DevOps, SRE, platform engineering, technology. What do you think? What do you like? What you don't like type of questions. So yeah, feel free to ask any sort of questions. We're here.
Food as well.
Oh, yeah, absolutely. What's everybody's favorite food?
Pizza.
Korean for myself. I think I would die without Korean food. Like, you think I live in like Koreatown, so that's
nice.
That's very helpful here.
We have a question around pricing. So from a pricing perspective, is Shipa has a free tier perspective, which you can get started, and you can move. And then Shipa has Pro and Enterprise. The difference between free and pro is Shipa free has a limitation in terms of you can sign up at apps.shipa.cloud. And it has a limitation in the number of apps you can run, plus some of the security posture, kind of more enterprisey features, such as SSO, for example. And once you want to get into that, kind of connecting to AD and some more enterprisey features, then you go to a pro plan, we call. And if you need super enterprisey features, then that's the enterprise. But a pro version does not have limitations in number of apps, so it removes. But you can get started for free. One of the things that it's good to mention is a consumption model. So it's just like Amazon, right? Where Shipa does not charge you upfront for the number of users and so on. You only pay for what you use. If you're not using, you're not paying. And it's per application per minute. And you can find the price in the website. It's 0.00 something cents. I never remember kind of the exact number, but it's a consumption-based model. I hope that helps. I'll throw one your side, Ravi. Is that okay?
Sure, absolutely.
So the other question is this almost equivalent to what Rancher is to Kubernetes cluster management in addition to application management? What do you think there?
Yeah, so like I kind of take a more kind of like a one step up from that particular question. Is that like if you have tooling in place like Rancher, like I'm a huge fan of Rancher. I always like their cows, the cattle place, and all their cow metaphors. Is that Rancher is very infrastructure focused, right? And so as a developer, it's a very prudent use case for a platform engineer or a DevOps engineer or a system engineer or a cloud engineer. From a developer standpoint, knowing that a pod is healthy, it doesn't tell the entire story, right? It's like, okay, like the health check passed and the pod is, it hasn't crashed. There's no crash back off loop, but picture yourself in this situation, right? It's more easy to role play. Imagine you just started on a new team. Who hasn't started on a new team? This is your very first team you ever been on, but eventually you started a new team. And if you have to make a change to something and you find out that it's running in Kubernetes, just imagine what you have to do to figure out, right? Like on your local environment, it's fine. You know what? You have K3D, Minikube, you have a dev cluster, you don't care what it creates. but it does matter for that running application, right? Because if you haven't used Kubernetes before, it generates lots of objects, a lot of resources. I've been using Kubernetes for 5 years, and I'm still confused. Like, I hate to admit it, right? Like, it is so confusing because you can keep changing the opinion. And so having that application map that the Shipa has is super helpful, because like, oh, these are the 3 manifests that I need to touch, right? Like, this is what made up the application, or even more so, specifically networking is always my weak point. I mean, this is talk for another story. My biggest outage with networking related. It's easy to see that visualization. That's what sold it for me to come, like, this is my for 60 days here in Shipa, and it was like, yes, this will solve a lot of pain. So long-winded answer, but infra versus apps not there.
Yeah, I agree with Ravi. So it's putting an application definition on top of Kubernetes, right? Rancher is great, spinning up clusters, managing cluster health and pods and so on. But if you want something that can scale across your organization, then having an application layer on top might help you a lot. Again, across monitoring, across definition, service ownership, and visibility, and so on. And later on, as you scale to new clusters, using Rancher or any other the managed providers, you're free to do so. Or if you want to use GitOps, or if you want to use Terraform or Pulumi, then you're free to do so, because then experience is the same, because you're dealing with applications. So anyone who is interfacing with your platform is using that. So you can do that.
And one more quick adage about Ranchers, that we actually just got into the cattle place. So we're actually very good partners with Ranchers. So there's one click to install as of last week. If you go to the cattle place partners and see the Shipa icon, we're in there.
That's right. We got another question regarding how does Shipa compare to Oracle Verrazano? I might be pronouncing it wrong.
It's like a bridge, right? Verrazano Bridge. I know there's one in New York called the Verrazano.
I don't know.
I'm looking it up right now. So
I had the same thing. I was actually typing it right now. To be honest, I don't have much information around because it may be a very new service or may not. I have not spent time looking at it to give you a definitive answer. I might be completely wrong on what I'm going to say here, but most of these services, they are very opinionated to work on top of their own cloud and their own cluster, and kind of using in one specific way to manage kind of from an infrastructure as code perspective. Shipa is an application layer on top of these things. In our space, everyone rubs shoulders with everyone. I think there is a lot of similarities across a bunch of different tools. But Shipa in that case detaches the application from the infrastructure. So it allows you to use Oracle cluster, OKE, but also gives you GKE, AKS, Rancher, so many. So you can move things around without kind of changing that application experience. I may be wrong. I don't know their service. If I am, Oracle folks on the call, I'm sorry. I'll do a better job, but that's kind of
I gave it a Googling. So as you were explaining, I took advantage of you explaining it to look at what it did. So my, again, like, just looking at it for the first time, looks like Verrazano is like App Engine or Elastic Beanstalk. So it's like all packaged in one. It's specifically for Java workloads. So like, and then actually the target infrastructure is Oracle Kubernetes infrastructure. So your explanation is actually spot on. Like, they try to bundle, for ease of use, or it's basically providing a cloud path that for Java applications to be deployed on Oracle Kubernetes engine. So yeah, potentially, right? If taking your explanation was perfect, Shipa is more abstract than that, right? So it's focused on the application, so not necessarily you're building specifically to Verrazano. It's like using a PaaS. You're building specifically to Tanzu. You're building specifically to OpenShift. The one thing we didn't talk about, and one click into Shipa, is that we're actually pluggable into multiple pieces of infrastructure. So if you don't like the opinion of something, Shipa doesn't care. If you want to use, instead of, I'll pick on Red Hat because I used to work there, like if you're using OpenShift and Tecton pipelines, you don't necessarily have to use Tecton pipelines. You can use Argo or Flux for like another CI/CD service. And the list goes on. Like, if you don't have to be using HA proxy or a particular service mesh or English controller, we plug into like several of them, right? So it's where our opinion is as pluggable or more pluggable than the services. So hope that answered your question.
Yeah, and just extending one bit on that is one there's a policy part on Shipa, right? And these policies are scalable across a bunch of different environments, and you can customize the policies and bind these policies on OKE and other clusters. That's one part. I don't see that on the website, how they deal with that. If you have to get into legal rules, then as you scale, it's going to get super complicated. So that's one part. Second part is, I don't know if they do that as well, because again, it's a new service. Shipa can plug into your existing namespaces, right? So let's say you already have a cluster, you have 50 services deployed across 5 namespaces. When you can probably still see my screen, but one of the things that you can find in our policy is this part here, app discovery, right? So your policy framework, when you're creating a policy framework, you can come here and say, connect to an existing namespace. When I bind it to a cluster, I want to connect to an existing namespace project 1, for example. You can pass it on here. And in the app discovery part, you can come here and say app, or give the labels that you have used to deploy applications in that namespace. When you do that, Shipa will start immediately importing and start giving you views over your application and the dependencies and so on. So you can plug into existing stuff because we recognize you already have might already have applications deployed using Helm, Customize, Terraform, Pulumi, GitOps, whatever that you're using. So Shipa plugs into an existing environment as well, which may be different from Verrazano if I'm pronouncing it correctly and if I kind of can read it correctly. So that may be another difference.
Looks like we have another question about opening up our API. I'm not sure if you want to talk about that, or we have another panelist on here, or another person in the audience who will talk more about that, but he's hiding. So not mentioning names in the panelists. So, yeah.
True. So Shipa, the funny thing is Shipa has the API reference already built and available here. So everything that we're building, kind of the policies, applications, binding into clusters and alerts and events and webhooks and all of these API calls, they are available and documented here. As we grow and evolve Shipa, those are going to evolve as well. And one example of how powerful or how cool it is you can get this thing and use it to build another provider. So that's how we started kind of building the interfaces into Terraform or the interfaces into Pulumi, Crossplane, is basically having those other tools, leverage the API, or if you want to embed that into your own automation or own product as well, you can have that here. So all the kind of identity provider, application, policies, and so on, you can find those events documented in the documentation. It's under learn.shipa.io. If you come here at the top, you can find API reference. That's where you're going to find the complete API documentation. Man, I talk a lot.
Lots of great questions. And also we have our little off topic too. We have our open source framework called Catch. And so, we're always looking for contributors. I mean, shameless self plug here for the Catch. So, there's definitely ways to extend that as we're actively accepting public PRs.
Yeah, I think we answered the questions.
Anything else, friends? Looks like that was it.
Mm-hmm.
Well, Bruno. Awesome. Yeah, well, thank you everybody for your time today. Really enjoyed, having the chat, and very interesting demo for sure. And yeah, if anybody has any questions, hit the Shipa.io. We're always available. Like, see a couple of conversations going on Slack. Feel free to join our Slack. If you haven't signed up for Shipa Cloud, just go to Shipa.io, click sign up. We can now do a big announcement. We can now do OAuth authentication and authorization. So you can just sign up with Google or GitHub, and no need to give us your email address. So making moves on Shipa Cloud.
Exactly. Thank you everyone for joining. I just sent to everyone the message, apps.shipa.cloud. We would love to hear your use case and build with you. Shipa is still in an early stage. There's so much that the team has built, but there's so much more to do. So we'd love to hear your use case and build with you. I appreciate everyone taking the time today.
Thanks, Bruno. See you, everybody.
See you, folks. Bye.